Hello, my chemistry pals. Today we will be discussing the nitrogen and oxygen gas buffer system that divers experience when ascending and descending, and what happens when the system is disturbed, which is called nitrogen bends. To begin, dynamic equilibrium is achieved in a reversible reaction at the instant at which the rate that products are being formed is equal to the rate that reactants are formed. In other words, the rate of the forward reaction is the same as the rate of the reverse reaction. This can be described in two simple equations. The first being A plus B equals AB, or AB equals A plus B. Equilibrium will remain unchanged if and only if the system is remained undisturbed by external factors. Some external influences that have the capability of causing a disturbance in dynamic equilibrium are temperature changes or the addition of excess reactants or product molecules. The bends is an example of homogeneous equilibrium because all the species involved remain in gas phase. Another important concept to understand is
Le Chatelier's principle. Le Chatelier's principle
states that when a chemical system is disturbed at equilibrium, the system will react in a way that opposes the change. For example, let's say that a reaction between hydrogen gas and iodine gas produces hydrogen iodide alongside with 125 kilojoules of heat. If the exothermic reaction was to be amplified in a way which would produce an increased amount of heat, it would therefore be true that an increase in the amount of products being made would occur. Consequently, and in accordance to
Le Chatelier's principle,
the equilibrium reaction would shift to the left, or in other words, the reaction will become reactant favored, meaning more reactants would be formed. In this case, an increased amount of hydrogen gas and iodine gas would be formed in the reverse reaction.
Le Chatelier's principle
Is built on two fundamental ideas. The first and most notable notion being, if a catalyst is added into a chemical reaction at equilibrium, the rate or speed at which the forward reaction occurs will be equal to the rate or speed that the reverse reaction occurs at. As a result, it can be said that a catalyst, in essence, causes a chemical reaction to reach dynamic equilibrium faster. So how do these two principles relate to the bends that divers experience? I'll get into that momentarily. First, let's define what happens when a diver experiences the bends. The bends occurs when dissolved gases, mainly nitrogen, come out of dissolved solution in the form of bubbles, which negatively affect the body. The most notable areas include the joints, lungs, heart, skin, and brain. When the bends occurs, the diver feels a significant amount of pain. There are three main factors that affect the severity of the bends. The first being exertion. Exertion is loosely defined as the intensity or workload done by the diver. The more exertion done by the diver, the higher the probability of spiking or increasing their blood flow and ultimately increasing the blood's efficiency to carry nitrogen throughout the body. Since the diver's blood is traveling at an accelerated rate, more nitrogen gas is consequently dissolved in the blood, which imposes a devastating limit on the lungs' ability to filter out the precise amount of nitrogen to keep the system in equilibrium. The second factor is thermal stress. Thermal stress basically means that the temperature of the diver's body can affect the rate of bubble formation. On one end of this spectrum, warmer blood absorbs and releases more nitrogen gas, while on the other end, colder blood collects and removes gas at a slower rate. The third and final factor is air mixture. The gas inside a diver's tank can affect the rate in which nitrogen is absorbed into the blood and removed from the blood. Enriched air nitrox, a commonly used compound stored in divers' gas tanks, possesses a higher concentration of oxygen as compared to nitrogen, which therefore causes a reduced intake and release of nitrogen gas in the blood. Now let's get into the fundamental idea and the cause of the bends. As previously stated, equilibrium occurs when the forward and reverse rate of a reaction occur at a constant rate.
Le Chatelier's principle
States that when a system at equilibrium is disrupted by a thing such as a change in concentration, pressure, or temperature, the equilibrium position shifts to counteract the disruption in order to maintain a constant rate of production in both the forward and reverse directions. When a change in pressure occurs, scuba divers rely on
Le Chatelier's principle
to take place in order to restore a constant rate at equilibrium. The air we breathe at atmospheric pressure is comprised of roughly 20% oxygen and 80% nitrogen. At generic atmospheric conditions, the body is naturally able to break down oxygen and nitrogen molecules. When standard atmospheric pressure conditions are achieved, the body absorbs oxygen and very small amounts of nitrogen. In these conditions, nitrogen cannot be fully dissolved into the body with this amount of pressure available. However, when the conditions of pressure changes, the body's ability to intake gases changes as a result. Deep below the surface, pressure changes at an increasing rate the farther traveled in the downwards direction of the diver. The reaction between oxygen gas and nitrogen gas can be represented by the following equation. At equilibrium. This equation accurately represents the equilibrium equation which divers experience as they decline or reach lower points under the surface. A diver's oxygen tank is commonly comprised of two common gases, those being nitrogen gas and oxygen gas. When the gases are inhaled, both gases will dissolve into the body in the form of nitrogen monoxide due to the constantly increasing pressure that the diver is to experience. The opposite is true when the pressure is decreased. As a diver ascends, pressure begins to gradually decrease, causing nitrogen monoxide to decompose into its reactants, which are oxygen gas and nitrogen gas. In order to maintain an equilibrium balance in the body, divers will ensure that the rate at which they descend and the rate at which they ascend is constant. This is very important to note, especially in relation to
Le Chatelier's principle.
when divers dive, the pressure is constantly increasing the lower the altitude achieved. As a result, the nitrogen being inhaled is prevented from escaping the body through exhaling. Your body, in an attempt to maintain equilibrium and an attempt to keep
Le Chatelier's principle.
intact, will proceed to absorb the nitrogen into its tissues and bloodstream, causing an equilibrium shift towards the production of nitrogen monoxide. This process is completely safe, all as long as the equilibrium is maintained. In opposition, as a diver ascends at a constant rate, the equilibrium will be upheld. But what occurs if this rate of ascension is not held to a constant? It is an important fact to note that nitrogen gas is constantly being dissolved into the body, although mainly in the blood, due to the high pressure levels. To accurately describe the process, this example is going to be focused on what occurs within the blood of the scuba diver. For example, let's say an inexperienced diver begins to ascend in an accelerated manner. The pressure would consequently begin to decrease rapidly, causing the balance found in equilibrium to be disturbed. Since equilibrium is eradicated, therefore,
Le Chatelier's principle.
is no longer holding true. As a result, this causes the rate at which the bubbles are dissolving into the scuba diver's blood to increase. This is a very dangerous process for the diver to undergo, considering that the bubbles are capable of blocking the natural flow of your blood. As a result, the diver will experience varying levels of pain in a variety of systems, including the skin, blood vessels, joints, and the brain, which is directly related to how fast the said diver accelerated towards the surface. In conclusion, it is very important for a diver to be aware of how the nitrogen gas and oxygen gas equilibrium buffer system operates when diving. If the diver does not ascend or descend at a constant rate, the erratic changes in pressure caused by the water can result in the formation of nitrogen bubbles within the body. The bubbles can cause the diver to experience very painful symptoms, also known as the bends, and can be fatal if treatment is not received within hours of experiencing the bends.